the algorithms are available, and how far we are going to do with kind of applications. And moreover, like how it is going to be impact on the complete design or model design. So once we complete the theory, like we'll go for practical sessions on afternoon, right? So practical sessions எப்படி கொண்டு போறது, எப்படி இது அண்டர்ஸ்டாண்ட் பண்றது அப்படிங்கறத we will go for it actually. The first and foremost thing what we want to cover here is very simple. Hopefully yesterday you would have come across some supervisory learning models actually, right? Can anyone tell me can you say me what are the models you have come across here? I want the session to be more interactive, that too by the morning 10 o'clock. So please be interactive. It's like it's a lunch section, I can understand, but in a morning session itself, like you can come up what you have seen yesterday, and we can discuss more on it, because we are going to combine the models. So that is what we call ensembling. So when we want to have an ensembling of models, so we must know about what are the classifiers which are available, and then how to link it with, and where do we want this ensembling methodologies to be done. So hopefully I want the things like what classifiers you have seen yesterday, so that it will be better, it can be easy for me to take forward. Please, can anyone tell me like what are the classifiers you have seen yesterday? அப்பா எதாவது பேசுங்களேன்ப்பா. Classifiers, we are making out the concept of classifiers because we are making in hybriding the models. So classifiers அப்படிங்கிறது ரொம்ப முக்கியம். So classifiers, do we have that kind of classifiers over here? Okay, I'll just explain it. So first thing, in the yesterday's session or day before yesterday afternoon, we saw about supervisory and unsupervisory model. In supervisory model, we have inputs and outputs, something we talked about, and unsupervisory, we only talked about the inputs. Now the things which are being very clear about this logic is like the supervisory learning, where the inputs and outputs are fixed actually, right? So there are a lot of algorithms. We'll take one case study which you have seen it, and then we can go further. So supervisory learning, there are a lot of things to start with. We have ANN, and you have random forest, and you have decision tree, and then we have KNN, and we have SVM, and lots to more, right? So this is the logic. Now, for to basic understandability of ensembling in sense combining these two models actually. So you can combine this ANN with RF, you can combine with RF with DP, you can combine this KNN with SVM. So these are the terms are called as the ensembling methods. But when you want to understand what is ensembling, what is the ensembling mechanism, how do we ensemble the methods, that makes the difference. So how do we ensemble the methods, and how do we ensemble all lot of things actually combining, every combine பண்றது அப்படினா we must know about the pits and falls of one supervisory learning model, and then we can interface with the two things. Now the ensembling, I just make it in two terms. Ensembling, we can have first and foremost thing is hybridization of two, that is hybrid of two supervisory models, or two models can be hybrided, and you can combine any unsupervisory supervisory model to the supervisory model, that we have different cases. So we'll see one by one. So this is the logic. So we'll have this hybrid of two models, and unsupervisory to supervisory, that is you can combine unsupervisory model supervisory model oda combine பண்ணலாம். ரெண்டு செஷன்ஸ் இருக்கு. So we'll see one by one. So first of all, like why do we want to ensemble, எதுக்காக ensemble பண்ணணும், ஏன் hybridization பண்ணணும்? Best thing is to increase the performance of the model. Simple. So to increase the performances of the model, to increase the performance of the model, That is why we are ensembling the concept. So we are ensembling because of the increasing performance. We'll talk about in the practical performances. How to make it out, all this sort of stuff. So performance is increase பண்ணணும். So the performance will not be a common term, right? It won't be. For example, SVM we'll got around the performance is around like 60% when I hybrid with model, if I get 80%. So this is what we called as the 65% and 80% we'll talk about later. The performance is increased அப்படிங்கிற கான்செப்ட்டுக்கு வரும். So that is the performance to increase. So why hybriding, why ensembling அப்படின்னா first and foremost reason is to increase the performance of the model. ஒரு performance மாடலோட performance increase பண்றது first. Second, you have different kinds of multimodal data. For example, multimodal data இருக்கு. So first is to increase it, and multimodal data இருக்கு. Multimodal data na we have different aspects of data. The most important is different aspects of data. Different aspects of data அப்படின்னா, for example, you may have text, and you may have image, you may have voice, everything, right? So these are called as a multimodal data actually. So different data, different heterogeneous data. So the different heterogeneous data are there in the case. So appdi and the heterogeneous data irukumbodhu, and the logic which comes into the picture is something like we have to take over this kind of hybridization. So hybridization and the edathila nama poi aganum, which is the logic which has been taking place over this mechanism. So here we have to understand clearly, where we have to understand clearly that whenever we do some applications, these are the two important things to handle the multimodal data. And most important application is to increase the performance of the model. Particular model or performances are increase பண்ணனும்ங்கிறதுக்காக தான் ensembling போறோம். Now to ensemble or ensemble பண்ணனும், ரெண்டு மாடல் ensemble பண்ணனும்னா first we need to draw the base model. Baseline model என்ன அப்படிங்கிறது ஃபர்ஸ்ட் தெரியணும். பேஸ்லைன் மாடல்னா என்ன அப்படிங்கிறது ஃபர்ஸ்ட் தெரியணும். And based on that it has to be designed. So இப்போ we'll take one base model, designing of one base model. Two base models கூட எடுத்துக்கலாம். I'll take two base models. First model is I'll talk with ANN. So artificial neural network. The artificial neural network is known to everyone else. Now let me put on one simple question, right? So you people are all faculty members. How do you train your students? Do you perform supervisory or unsupervisory? How do you train your students? It's not a technical question. You can answer me this question through your messages or through by unmuting yourself. How do you train your students? எப்படி train பண்ணுவீங்க students? This is what the question. Supervisory. Good. It's a supervisory. What is the input and what is the output? How do you train it? What is the input and what is the output? For students, how do you train this? How do you train your students? It's a supervisory. Good. Best answer. So how do you call it as a supervisory? What is the input and what is an output? And how do you train them? Giving examples, label based. Okay, then any other answers? How do you train your students? For example, like pattern based. Okay, so pattern based training. Okay, so I like to know like what is the pattern based training? Right there. Okay, right. So let me have this basic example. training the students, right? What we do normally here is like, we will have some activities, right? We will have some examples of taking the classes. And for example, like, sorry, there will be some typo error. So there will be some examples of taking the classes actually. And then after taking the classes, right, after examples, you will have the test, right? And the test is kept to make it like, how come he can able to understand the logic actually. So the tests have been kept, and from this test, right, so we have the options. And based on the test material, right, so you would have trained it, and you will have some assignments, everything. And there will be the marks for assignments and everything. There will be some assignments and everything. So let us assume that each and every students have been given example to understand the logic, and the tests are conducted, and based on the test, he will get the mark actually. So let us say your pass percentage is 80 percentage, and if the students fails to get 60 or 80%, that is, he's getting only 58 or 60 percentage, what we will normally do? See, we train the students using examples, giving lecture notes and everything. Everything is over. Now he goes for an exam, write the test, and he got 60. But he has to get 80 for passing the examination, for the which is kept as a threshold. If he fails to get 80, what we will normally do? What we normally do? This is the question actually. So if he is being trained, and he has been trained in some with examples and everything, he's writing a test, he's got 60, but the percentage we have to make it here is only 80. So what we normally do? What the students will do actually, if he fails to get, let us say, pass mark, if he doesn't get a pass mark, so what he will do? Extra coaching. Okay, then retest. That's the thing. Again, preparation with the retest. Right? So we'll go for a retest, writing the test until he gets 80. If he gets 80, okay, leave it, right? That's all. Your target is achieved. He got the target is achieved, right? The same way, a similar way, we are going to train the ANN. The very similar cases. This is simple examples, right? So once what happens, you have input, your brain is your inputs have been given to the brain of the students, and then you're checking your output, right? So this is what the logic is. You're checking the output. So this is what we normally do for the training the students, right? So inputs, and then you have the brain, which is the input is given to the brain, where the brain is trained with your inputs, and from the brain it is given as an output. This is what the logic is. Now what we are going to do here is, for the ANN, we are going to replace this brain as a hidden layers, and then it is an outputs. So simple. So it is going to be changed. This is the three layer of ANN. We already know about it. Input, instead of brain, we have hidden layers, and then we got output as usual. Now these inputs are given to the hidden. Why it is hidden layer? We don't know what is the processing of the brain for a particular individual. We don't know about what is the process which is being taking place in this mechanism. So the thing which is being taking place over here is, we name this as a kind of a hidden layers, and the nodes which is present over here is we call it as a hidden nodes. Brain will have neurons. Similarly, we have hidden nodes, right? We have the hidden nodes to work on it. So there is the cases. There we have the hidden nodes actually. So this is the logic which we have to take care. So the hidden layers, outputs, and the hidden nodes. This is what the logic which we have to take over, and this is the mechanism which we have to make it here. So the things which is been doing over here, which is the case which has been doing over here, is something different. Now the inputs are passed to the hidden nodes, and from this hidden nodes it has been processed, then it has been given to the outputs. So this is the logic what we have to take care. This is the logic what we have to take care and what we have to work. So now the things which has been done over here, this is the thing which has been done over here. The logic which has been coming across here, the logic which has been coming across here is very simple actually. So this is the simple thing which we have to take care. Now this hidden layers and hidden nodes. The number of hidden layers will be different for each and every application. And we'll have some technical terms to understand. So the nodes with the numerical values. We have a numerical values that is most important. And this is known to be your bias weights. This is the logic. So this is the concept which we have to understand. So nodes with the numerical values are known to be the bias weights, and the layers are not going to be a same thing. It is going to be a different cases, right? And then we must know about these epochs. Epochs is the number of times required. These are called as the hyper parameter of the network. I'll repeat, it is the hyper parameter of the network. It's a hyper parameter network, right? The epochs is the number of times required to train the model. Number of times required to train the model. Right? Epochs is number of the times. So number of times which is required for training the each and every model. And then we have the batch sizes. So batch size is the number of inputs what is being given to the hidden layers. The number of inputs given for training. For example, let us say we have, I'll just give you the example. You have 5 units to train the students, right? So what you'll do normally, the 5 units is now converted into 5 single units, right? 5 single units. It is being converted into 5 single units. So the 5 single units are being converted over here. 5 single units are converted. Now, the each and unit which is being utilized for training, right? The first unit may take the students to understand. 45 minutes of time of lecture can make the students to understand. And the another unit is taking around 50 minutes. And another unit is being taking around 61 hour. Another unit is only 20 minutes, and another unit is around 50 minutes. This is what the logic is, right? Now what I'm going to do is, here the batch size is the first single unit, right? The total number of data is 5. So now the 5 is now converted into single batches. 5 data are converted into single batches. In one batch it contains one unit. So this is known to be your batch size, and the time which is required to train the model is known to be the number of epochs. So the total epochs which is used to train this 5 units is approximately 45 minutes, 95 plus 60, 150, and plus 20, it is 170 plus 220. So this is my epochs. 220 minutes is my epochs, and 220 times to train the 5 units with the batch size of each and every one unit is known to be the hyperparameter to train the model. So this is the logic which we have to understand. So I repeat once again, this is an example we have to design. This is the 5 units we have to train. This is the total number of data which we have to train it. And here this 5 units is subdivided into this kind of application, that is 1 comma 1 comma 1 comma 1. So that is 5 single units. This 5 single units is now converted. This is now converted into the best concepts of the batch sizes. And each unit is taking around 45 minutes to 60 minutes. Cumulatively, we can say it is 220. And this 220 is known to be the number of epochs which is being used to train your model. And the batch size is 1, because for each epochs, for the each time, I'm going to give 1 unit for training the brain of a student, and the total number of data for training is 5. So this is how we called as the hyper parameters of the neural network. So this is the logic. So hyperparameters of the neural network. So this is the logic which we have to understand. Hopefully you can understand what is the hyperparameter. Is it clear, guys? Hello? Guys, it's clear what is the hyperparameter? Yes. Now this is known to be the hyperparameter of this mechanism. This is known to be the hyperparameter of the device, right? So this is the logic, hyperparameters of the neural network. Now this hyperparameter is used to train the model. Then there is another important application that is called activation. That is called activation function. That is called the activation function. That is called the activation function, which is the mechanism which is being done over here. The activation function which is being utilized for this logic. Actually, this activation function is nothing but hello. So activation function is required, and this activation function is something like which is used to carry out your information from one layer to the another layer. It is used to carry out the from the one layer to the another layer. That is what we called as the activation function. So here we have a lot of activation functions which are available. So the activation function is like something like which carries the data from input layer to the hidden layers, processed all the outputs from the hidden layers to the output layer. So all these things comes under one activation function, which comes under one activation function. So that is the logic, that is the mechanism what we have. So that is the mechanism what we have over here. So now we have to understand clearly. Now we have to understand clearly. This is the logic which we are making out into this mechanism. This is the logic which we have to making into the mechanism. So the activation function is simple for that. Activation function is it is something like which carries all your inputs from layer to layer. So there are a lot of things which is there, sigmoidal, tan functions, and most importantly RBF, that is radial basis functions, Gaussian functions, and more importantly today we are working on the era of ReLU, that is your rectifier units. That is rectifier units which has been predominantly utilized in the deep learning applications. It is predominantly mostly applied in the deep learning concept. It is utilized majorly in the deep learning logic, right? So this is the logic which is being taking place over here. This is the ReLU concepts actually which is making out a solution for this. And this from this ReLU, that is from this ReLU which we have to take over. From this ReLU, this is the logic which we have to make over. And then there is another important thing which is being taking over here is like we have p-ReLU, that is parametric ReLU, which is being taking, and there is another concept that is called leaky ReLU. And then now we are working on this function, that is MISH activation function. This is a new one which has been taking place here. We have another thing which is called SWISH. So these are all the two trending activation functions which has been utilized in the learning models, which is to get the better results. The activation functions not only carries your data from one layer to the another layer, but instead it has to be a lossless data travel. It has to make it as a lossless data travel. That is, the data traveling mechanism has to be like it should be like loss oriented. It should not be like any lost data. If there is a loss of data while transferring from one to the another, then the training part will not be a constant one. So this is the logic what we have to train over here. So this is the activation function. So this is the hyperparameters which is been taking over here. So we must understand this actually. And then the next process what we come across here, the next process what we come across here is like there was a question before you. The question before you was very simple actually. That is, if we didn't get the model, if we didn't get the pass mark, what we will normally do? We normally used to train the student actually, which has been required, right? This is what we normally do actually. This process is known to be the back propagation process. So this process is known to be the back propagation. The back propagation is nothing but calculates the error in the output. If the error is 0, it leaves. Otherwise, it tunes your hyperparameters. It's clear, like it tunes your bias weight or tunes your hidden layers. So what happens here is like it tunes your hidden layers to get the particular output mechanism. So if this test is done, if this output is something, it's an error concept. So let me draw this actually. So if the inputs hidden layers and outputs, and you have got it. For example, as we talked about with the example 60, if the student gets 60 instead of 80, so this you have to understand the error is around 20%, right? The error is 80 minus, because this is the threshold which we have to make it out, so this is equal to 20. So until it reduces the 20, this 20 is taken as a feedback to train the hidden layers. It has been given to take your hidden layers. It has been given for right. So this is the taken as an input, or we can take it as a feedback. Feedback to tune the hyperparameters or to tune the bias weights until the error is 0. And this is known to be your back propagation mechanism. This is known to be your back propagation mechanism. This is the logic what we called as the back propagation mechanism. This is the logic we known as a back propagation. So we have come across different cases here. That is the first different cases which has been taking over here is the simple one. That is, first is something like we have this input hidden layers, output layers, and we have this hyperparameters. Back propagation. Back propagation is something like the error is taken into account and it is being given to the hidden layers to train your model. So it is used to train the hyperparameters of the model to get it back into the cases over here. Now we're going to ensemble it, guys. It's very clear what is the basic fundamentals of ANN. Guys, it's clear. What is the fundamental model of ANN which we are talking about? Because with this, we are going to ensemble it. Guys, it's clear. Any doubts? Because we have to solve this. Guys, any doubts? It's clear for you guys actually. What is the sort of ANN model is all about? Now we'll move on to this ANN model. So where do we ensemble this? So I take the first steps, right, for this. I'll take the second case and then we'll move on to the first case. So here, where do we where do we make it out? And before moving on to the ensemble, we must know about what are the unsupervised models which are required. So unsupervised models, why the unsupervised models are being utilized? We must know about this kind of applications and what are the algorithms which are required. First, the unsupervised models, based on that, we have the most important case that is called dimensionality reduction. So we have the case called dimensionality reduction. That is the case which we have. So the dimensionality reduction which we have to understand here is, in the dimensionality reduction, we are used to reduce the dimensions of the data. This is the cases where you have a huge data. So it may create a burden on the model. It will create a major thing or create a major thing in the model. So for this kind of a cases, we will reduce the dimension so that the model becomes lighter and less complex to handle the data. So this is a logic which we have to talk about. The first application is dimensionality reduction, and there is a one method which is predominantly utilized in the older method, that is PCA, principal component analysis. This is the logic. So principal component analysis. This is the logic which we have taken place over here. So the principal component, now what we are going, what there are the things like we have a most important algorithm called SMOT, right? This is the most important algorithm. This is being utilized in the dimensionality reduction to make it, to make the model as the better, to get the model lighter and less complex one, to make the model as a lighter one. So that we called as a SMOT model actually, which is a SMOT actually, right? And then today, like we have another model that is called relief. These are the things which has been taking place over here, the SMOT and relief. These are the things. And then there is another method that is called residual methods. Right? These are the residual methods which are being normally utilized for the data reduction and the attributes reduction, which is being utilized over here. So that is the logic which we have to take care. That is the logic which we have to take care for the mechanism. So that is the case which we have to take care, and this is the logic which we have to take care, and this is the mechanism which we have to start about. Now the things which we are going to take over here is something different. So SMOT, relief, and the residual methods. And then this, after this we have, with this all the dimensional reduction, and then we have meta hysterical algorithm. So meta hysterical algorithm, so this is the logic which we have to take care. It is the meta hysterical algorithm. So these are the algorithm which is being normally utilized. So this is one kind of mechanism which is being utilized over here. So that is your mechanism which is being doing for such kind of applications. That is, first is about dimensionality reduction. So where you can reduce the dimension and give the best results. I'll take one example and how to solve this, right? And the second thing is about like data grouping. So data grouping mechanism where we normally use the clustering mechanism, and then we have k-means. K-means clustering. You have a lot of things, k-means, f-means, and everything, right? So these are the things which is being utilized to group the data, only for grouping the data, and that grouped data can be utilized. If you want to find out the distribution of the data in the input. From the inputs, right? The distribution of the data from the inputs, right? The finding out the distribution of the data from the inputs. So that makes the sense. That makes the sense actually. So distribution of the data, that makes the sense actually. So from the distribution of the data, so in order to identify the distribution of the data for the each and every means, we need to go for this kind of technique, clustering technique. And the most predominantly this dimensionality reduction, these are the things which we want to go for. SMOT, relief, residual methods, and meta-hysterical algorithms. These algorithms are predominantly utilized to used to do for making the things as a major one. So this is the logic which we have to take care. So this is the concept of your simple unsupervisory model. I'll just take the basic thing, the meta-hysterical algorithm. Let us take this actually, right? I'll take this as a case study, and then I'll just combine with this ensemble. So meta-hysterical algorithm. Now, where do I integrate this? You have ANN. We talked about ANN. We have input and what you call hidden, and then we have output. So where I do it ensemble with meta hysteric algorithm, right? Where do we integrate this meta hysteric algorithm over here? So to start with, what is meta hysteric algorithm? Let me give you what are the things. It's all based on animals' behavior. Animals' behavior. For example, we have a lot of algorithm, bat algorithm. We have PSO, swarm, firefly, and we have Leo algorithm, that is Lion's Hunt. It's not a film, right? So it's a Leo algorithm, and we can have the basic mechanism. A lot of things actually. And we have Bhakti shark, that is white shark algorithm, whale algorithm, and a lot of things which is there. So nearly like 50 algorithms are there actually. So these algorithms are being designed based on the hunting nature and their basic characteristics of these people. There's the characteristics of these animals over the logic. So how does the characteristics of the animals do this logic actually? So based on that, it is been defined over here. Based on that, it is being defined over here. So this is the logic which we have to understand. So this is the thing, animal behavior. So there may be a question, how do I integrate this animal behavior with that of your what you logic, like with that of your neural network? There must be a question. There is a trivial question. Where do I just ensemble this? Where do I just ensemble this animal's behavior with the case of here? Now, this, where do we ensemble it? This is the next ensembling process. The first category. We have a lot of ensembles, but this is the first category. So the ensembling, like as we talked about, let us take an ANN. So you have inputs. Again, I repeat, outputs here. So where do I make it out? What is the role of this animal's behavior or logic with that help of your neural network? What is the logic which you can do for it right now? The thing is, as we talked about, we have to iterate. There is a back propagation method which we have to iterate continuously until the error becomes zero. Until the error becomes zero, it has to be iterated for a different logic. It has to be iterated for the different cases. It has to be iterated for the different categorizations, right? So what is the major drawback? Can anyone tell me? You have to keep on training the students until he wants to get the pass mark. What will be the drawback here? What will be the drawback when you want to continuously train the students until the students get 100% of marks? It's simple question. What will be the drawback actually? And that is our duty to get him on 100%. That is different. But what is the drawback if you want keep on training your use the logic for this kind of applications? Answers, please. What is the drawback, people? Right, guys? Can you tell me like what will be the drawback actually? Time then. Students would kill bore. Okay, normally if we also teach them, they will also bore. Okay, then. So we talk about the first thing, the time complexity. That is, the time complexity normally increases. This is what the logic. We have to understand the time complexity normally increases. It is normally increases. So what we normally do here is like to avoid this kind of time complexities, to make it the time complexity and to get the better results. So like training them will not able to get the clear concepts actually. So here this meta-hysterical algorithm is normally used to tune the hyperparameters. This may be a research work also, right? So which algorithm is utilized to get the best results? Hyperparameters. Tune the hyperparameters. Okay, so meta-hysterical algorithm tune this as a hyperparameter. How to tune this as a tuning the hyperparameters, because instead of getting the output backpropagation to tune your hyperparameters, these meta-hysterical algorithms will be utilized to tune your hyperparameters of the network. It is normally utilized to tune the hyperparameters of the network. So this is the logic which we have to take care. This is the concept which we have to take care. So the meta-hysterical algorithm has to be taken care, has to be made over here, has to be made over here actually. So hopefully you can understand where do I ensemble this meta-hysterical algorithm. So first thing is I do integrate this meta-hysterical algorithm to tune the hyperparameters of the model. It is utilized to tune the hyperparameters of your model. So to tune the hyperparameters of the model, this is being majorly utilized. It is a thing which is majorly utilized over here. This is the concept which we have to understand. It is which is majorly utilized over here. So based on that only, it has been taking care kind of an application. It is the kind of the application. So this is the logic. This is the logic which we have to take over the mechanism. This is the logic which we have to take over the mechanism. This is the logic which we have to understand. So here, this is the logic we need to take over here. And the ensembling, like ensembling is used to tune the hyperparameters of the layer. It is used to tune the hyperparameters of the layer, right? It is used to tune the hyperparameters of the layer. It is used to train the hyperparameters of the layer instead of the back propagation. And this has been done with the help of a function called fitness function. I'll talk about this fitness function in my practical session, how to fix this fitness function. This is the logic, or else I'll just give you the clue. So fitness function of each and every meta-hysterical algorithm has to be varied in order to tune the hyperparameters, which makes us to get the best performance of the results. This is what we are talking about, the best results, right? For example, if this is the cases like the 95 percentage is the case, right? 95% is your performance to be obtained. So in order to obtain the 95 percentage, the fitness function of that particular meta-hysterical algorithm has to be designed, and these hyperparameters are tuned in such a way to satisfy the fitness function in order to make the highest performances. This is what the three-way link actually. This can be a research proposal for you also to design the research actually, and to give the research ideology. You can combine these two things actually, but we don't know which algorithm has its own will get the best results, because each and every algorithm has its own drawbacks and its own complexities. So we cannot predict that this algorithm may be suitable for this, particularly for this kind of data. We cannot come up with the solution. So here we need to understand the logic. Here, this hyperparameters are tuned. The hyperparameters are tuned in such a way. The hyperparameters are tuned in such a way. Hyperparameters are tuned in such a way that this fitness function is to be designed, and based on that, it has been iterated according to this meta-hysterical algorithm. And after this tuning, we need to get around the maximum performance, and that maximum performance is designed based on the fitness functions. So this is how the logic works on, and this is how the functions work on. This is the logic which we have to take care about this mechanism. So this is the algorithm which we have to take care. This is the mechanism which we have to take care. So this is the concept, right? So this is the concept which is being taking over here. Guys, it's clear? Guys, it's clear. Why do we integrate meta-hysterical algorithm? Where do we integrate this meta-hysterical algorithm in a simple ANN? Guys, it's clear? Hello? Hello? Guys, it is clear? Why do we integrate? Why do we ensemble this ANN? Something a complex topic. So it's clear where do we integrate this ANN over here? Yes, please come out with this. Right. Any doubts on this? Where do we make it out over here? Guys, please reply me back. Actually, any doubts? This will be helpful for your research as well as for taking the classes. So any doubts, please tell me what is any doubts is there. I can clear you the doubts of this topic and I can move on to the next topic. Please message me whether you have understood or not. Yeah, how it's tuned, right? That's a question actually. That's what it will be tuned accordingly the behavior of your animal, right? For example, there's a lot of mathematical solutions which is involved here. So like if you have that bat algorithm, how does the bat behaves? Based on the behavior, the parameters are tuned. These parameters are tuned and the fitness function, and it is being iterated. In short, we can say these are iterated according to the bat's behavior to achieve that fitness function. Until the fitness function is achieved, it will keep on iterating until the bat may, and similarly like a bat's mechanism. For example, I'll tell you the basic example. The bat algorithm is the behavior, is the algorithm which is utilized. A simple algorithm. All the algorithms are there. It's simple to understand. Bat algorithms are there. This algorithm is utilized to find out its prey, right? It find out or prey identify பண்றதுக்கு இந்த bats என்ன procedures use பண்ணுது அப்படிங்கிறது தான் bat algorithm. Here for this kind of ANN, when you ensemble the bat, the number of bats are nothing but the hyperparameters. Prey அப்படிங்கிறது இங்க fitness function, right? So this will be iterated in terms of bat algorithm formula and see whether the fitness function is met. If not, it will be increased. If not, it will be increased to the next level. It will be increased to the next level according to the bat's mathematical formula. For example, 0.45 plus 2 add panna, it will go for 2.45. அப்படிங்க batல இருந்ததுன்னா we will add it to and again we'll check the fitness function. If it met with the fitness function again, then it will go for okay, then it will go for it and then go for the logic. இப்படி தான் tune ஆகும். So we will take the bat's behavior, bat algorithm of behavior, and from the it will be given to train the model. It will be given to train your hyperparameters. This is the procedure. So clear, ma'am? Is it clear? Thank you. Thank you. Thanks a lot. Right? Any other doubts? Any other doubts? Because this is most something like tricky topic, and moreover like it is also most important research topic also which has been there actually. So please come out with your doubts so that I can clear you. Doubts are clear? Okay, so this is one kind of ensembling where I just ensembled the meta-hysterical, that is we name it as one of the category of unsupervised learning, and here this is kind of with the tuned hyperparameters. Instead of it's like it is something like we do for post processing. It's a pre-processing of tuning the data, fix it on the model, and the model runs. Simple. This is what the logic, right? And what is the advantage of this is like major advantage of this kind of ensembling. The advantages in this kind of ensembling is gradient problems. That is the variant gradient problems will be overcome. So will be taken care. Will be like will be eradicated. So the gradient problems will be eradicated. So this is what the logic which we have to come across. So gradient problems, if the model has the gradient problem, definitely there will be the major problem in the data losses. It may be because when you take a feedback from the backward side, definitely it will be the there will be the error, and there will be the mechanism which has been taking place over here. There will be the error which has been taking place over here. So this is the logic which we have to come across here. This is the logic which we have to come across here. And that is the logic which we have to take care. So this is known to be your gradient problems, variant gradient problems. This is the logic which we have to take care. So this is the major advantage. And moreover, the time is also be reduced, because when you tune it based on the output side and all other things, the time parameter normally increases. So this time and performance, time reduces, performance increases, and it overcomes the problem of variant gradient problems, which makes the data losses while taking the feedback from the back propagation. This is what the ensembling, first kind of ensembling meta-hysterical with your what you call as the in a ANN or any supervisory learning. Now, second ensembling method. Now I'm going to play the video for you for this case, and there will be the questions to you, and please answer the question which is more important, right? I'll play the video as usual for my film. Please hold on a second. There will be a video for you for the 2 minutes. Please look on the video. There will be the questions, and then we'll move on to what will be the cases over here. The second ensembling technique. Sorry, legless problem actually. 1 minute. I just rectify this.